Mold, like most living things, likes water. And so if there's been a water incursion, a whole bunch of mold grows, and then it runs out of water and stops growing, and the volatiles dissipate. You could have an enormous amount of mold damaged material hidden behind walls or in vents or someplace that's not visible. And because of the absence of active growth, you might not smell it. The phrase in the trade is just add water.
Hello, everyone. My name is Kendra Seymour, and welcome to your Indoor Air Podcast, brought to you by Change the Air Foundation. I'm joined today by Dr. Joan Bennett. Thank you so much, Dr. Bennett, for being here.
Well, thank you for inviting me.
For those who don't know Dr. Bennett yet, a little bit about her. She is an amazing woman. She has received her PhD from University of Chicago and spent over 30 years on the faculty of Tulane University in New Orleans, Louisiana. And since 2006, she has been a distinguished professor at Rutgers University, where she also served as the Associate Vice President for Women in Science, Engineering, and Mathematics. She is the past president of both the American Society of Microbiology and the Society of Industrial Microbiology and Biotechnology. In 2005, she was elected to the National Academy of Sciences, and in 2021 was elected to the American Academy of Arts and Sciences. Volatile organic compounds are low molecular weight molecules that easily evaporate at room temperature. Fungal VOCs are responsible for the musty odors we associate with damp indoor environments. It has been hypothesized that they contribute to sixth building syndrome. The Bennett lab has developed several genetic models, systems to test the toxicity of fungal VOCs, and found that VOCs have a range of unexpected biological functions. So that's what we're going to be talking about today. We're going to talk about those odors that are produced by mold growth, what they mean, and what that's telling us possibly about our home. So, oh my goodness, I can't wait to jump in because I think this is an area as a homeowner or a renter, the more we understand our home, the better we're prepared to take steps to make it the healthiest environment possible. So my first question, just to kind of set the stage for everyone listening, is what are VOCs?
Well, the difference between a volatile substance and what might be called a permanent gas is a volatile substance is something that's usually found as a liquid, but when it hits an air interface, can evaporate and turn into a gas. Something like chlorine gas, it's a permanent gas, it's a gas all the time, but something like alcohol, which famously evaporates if you just leave it out, is an example of a volatile. And there are many substances that are in our cleaning supplies that are volatiles. And for those who work in laboratories, it's easy to think of volatile substances like chloroform and acetone, which are used as solvents. And then maybe the most famous volatiles of all are the volatile anesthetics, ether, and more modern versions of ether. These liquid substances that, when they meet the air, quickly will turn into gases and disperse. And I'm not sure if all of them have odors, but what I am pretty sure of, but neurobiologists have told us, is that the things we smell have to be volatile. And so the compounds that we detect with our olfactory system are in the volatile state. They have become gas-like and they go into our amazing nervous system.
Yeah. So some of the things we smell are good, like fresh baked bread or cinnamon rolls, or if you ask my son, bacon. But some of these things are maybe not. So let's talk about that, because a lot of people, when you talk about mold, and you and I talked about this before, there are generally two things that come to mind. They think that one, you know, somebody might have an allergy. Or they think, I know mold, it's that musty smell. It reminds me of my grandma's basement or the cellar. And, we even have people who actually live in a home, they may even become desensitized to the odor. They don't even smell it anymore. So talk to us about, what are we smelling when we smell that musty odor? And what does it mean for our home and even our health?
Well, let me back up one step and the business about not smelling it anymore. One of the attributes of our sense of smell and of volatiles is that we get desensitized. We get used to it and you habituate. And so I think we've all had that experience. Say you walk up to someone who's wearing too much perfume and it knocks you over. Um, After a while, you don't notice it, and that's one of the ways in which smell works. And so if you live with an odor all the time, you may not be smelling it. You may not be mentally aware of it. So um, before going on into what the mold volatiles are, there's been a moderate, not an enormous, but a moderate amount of research on trying to figure out the compounds that create the moldy odor. Some of that research has been done under the auspices of food science, where we have a lot of modern food technology. And say you're wanting to make canned mushroom soup, what is it that you want to have as the flavor ingredient in there? And odor and flavor are very closely related. And there are those who say most of what we think we taste is actually what we smell. And so that's group of scientists has worked out. And molds make somewhere about 300 described published volatile substances. That's not an enormous number, but it's not trivial. Of that 300, there are a few that are found much more commonly than others. And the one that was the very first described is unusual that unlike a lot of chemicals which have complicated chemical names, it has a common name. And the common name is mushroom alcohol. Or actually, it was discovered by a Japanese scientist way back in the 1930s, and he called it matsutake alcohol. In English, we usually call it mushroom alcohol. And it's a small 8-carbon molecule, and it happens to be the one that I have focused on in my own research. It definitely smells moldy.
Yeah. So when mold or bacteria is creating this odor, my understanding is that it's because it's actively feeding, right? It's digesting, it's substrate, whatever food source, whatever it's growing on. Am I understanding that correctly?
Yeah, well, there's less research on how these compounds are made than one might like, but um, mushroom alcohol and a number of the other mold odors are breakdown products of fatty acids. It's not like there's a long dedicated biosynthetic pathway the way there might be for certain fungal toxins or something. You take a molecule that's already there and then use a couple of enzymes to turn it into something else. And so mushroom alcohol is a breakdown product of linoleic acid, which is a fatty acid that's known in many other fields. And fungi of the organisms that have been studied seem to be the ones that have developed the most enzymes that do this very efficiently and make a lot of the particular volatile compound.
Yeah. So when we are smelling, and we just described it as musty odors, but sometimes there's some variants people will describe,
Right.
like wet socks, or like, is there anything that accounts for the variance in odor that happens
Well,
with mold and bacteria?
certainly because it's not that it's just one thing. And anytime you're smelling the fungus, it's probably a cocktail of 20 to 30 compounds. And what in my own attempts to follow this, I found that if you check a growing mold colony on day one and analyze its volatiles, and then check it on day 2 and 3 and 7 and 15, you'll get a different volatile profile every day. Not only that, what you grow it on will change what the volatile profile is. And if you throw in a different organism, which is what happens in the real world, that will change the volatile profile. And so it's extremely dynamic, it's extremely complicated, and it's hard to come up with a realistic description of this amazing mixture of gas phase compounds that we're living in that are regularly changing as the fungus grows. as the fungus meets other organisms, other fungi, bacteria, etc. And there's a paucity of research. I think it could be better studied, but it's very hard to get the appropriate funding.
It is. It is. We have a lot more unanswered questions than we do answered ones.
You
Um,
said it.
yeah, yeah. So that's something I'd like to see change. Of course, that's a passion of ours. So it sounds like there's this variance of odors, what it's growing on. Sometimes people will say, we'll say, have you ruled out water damage or mold in your home? And they'll say, I don't have a musty odor. I don't have a problem. So is the absence of that odor, assuming the person hasn't become desensitized to it, is the absence of that odor, does that mean that your home is safe?
Not necessarily. And I think especially when mold has stopped growing. And so mold, like most living things, likes water. And so if there's been a water incursion, a whole bunch of mold grows, and then it runs out of water and stops growing and the volatiles dissipate, you could have an enormous amount of mold damaged material hidden behind walls or in vents or someplace that's not visible. And because of the absence of active growth, you might not smell it. The phrase in the trade is just add water. If some water gets in and there's been this previous mold incursion, you have a lot more inoculum. You have a lot more to start with, and the second round can be far worse than say the first water damage. So yeah, there you have to go looking for it.
Yeah,
Also, you have to point out there's mold everywhere
yeah.
in a normal room. There's mold. If you were to put out a petri dish, you'd isolate mold. And part of our amazing physiology is we're inhaling hundreds, thousands of spores a day in a normal environment. For most of us, we just handle it very nicely and they don't hurt us. It's
Yeah. And I think that's important. I'm glad you brought that up because, we don't live in a bubble. We live in the real world. And I think the focus here for people to understand is that when you're talking about your home, your indoor environment, your school, your building, your place of work, what we're talking about is that growth, and any byproducts produced by that. So, and regardless of species, if you have water damage and mold and bacteria growing, you're going to want to remove that safely, right? At
right.
the end of the day, it's releasing, and we're focusing on mVOCs today, things into your environment that can impact your health in a myriad of ways. And so, yeah, we want people to not be scared. We want them to understand what's going on and what that might mean for your health. So the presence of an odor can be, it sounds like, an early
Right.
indicator of a problem, but the absence of an odor doesn't necessarily mean there isn't mold or water damage there. It could be dormant. You're just not smelling it, other reasons. So I want
Well
to
put.
yeah, I want to talk about, I've heard you speak before about how Hurricane Katrina in 2005 was a bit of a turning point for you. Please set the stage for that because I think it's really interesting to hear about kind of your evolution there.
Thank you. Yes, as you mentioned, I was on the faculty at Tulane University for 30 years, and Tulane is happily situated in a wonderful American city, New Orleans, that's near the foot of the Mississippi River. And the reason New Orleans is built where it is, it's basically the first place you can put a city in a very low-lying area of swamp. And so New Orleans has always been surrounded by water and had water issues. And in modern times, the city has expanded to take over areas that used to be swampland and are below sea level. When Hurricane Katrina came, the levees that protect New Orleans from the Mississippi River held just fine, but the levees that protected New Orleans from a huge lake north of the city did not. And the city flooded to sea level. The city had expanded so much that it was 80% underwater. And the old part of the city, the French Quarter, etc., was above sea level and didn't flood. But I was in the wrong 80%. And my husband and I got a little over 3 feet of water, 42 inches. And so it's a lot of water. We weren't there. The National Guard and the U.S. Army Corps of Engineers were involved in pumping out the city. And so when we got home 5 weeks after the flooding had occurred, our rugs were still damp, but there was no standing water. And there was mold growth everywhere. Because I'm a scientist and because my specialty happens to be filamentous fungi who make agricultural mold toxins, I had the forethought to travel with sampling equipment, namely petri dishes and some things to use to grow the mold in the petri dishes, and then personal protective equipment. I had gloves, I had N95 masks, I wore long sleeves, and I sampled my house and took pictures. And it was depressing work. It's really hard to see a lot of your own beloved possessions that may not have been valuable antiques, but they were our furniture, my husband's grandmother's table, my mother-in-law's china cabinet, stuff like that. It was hard to see it underwater. And it smelled horrible in the house. And as I was sampling, I started to feel sick. And the fact that I was wearing a mask and wearing gloves and having long sleeves made me realize that it was very unlikely that I was getting in contact with fungal spores or fungal particles. That about the only thing I could have been getting in contact with were these little gases that pass through masks. And the fact that I was personally feeling sick and that the odor was so strong made me decide that if I got a new lab and if I survived Hurricane Katrina, I should study those volatiles. And that's just what I did. My husband happens to be from New Jersey. We had evacuated to New Jersey. I had made the media to sample my house at Rutgers University. And in that post-Katrina mood, when all across the country, Americans were really being nice to people from New Orleans, Rutgers took me in, and they first gave me a temporary appointment, and then they hired me permanently. And I've been on the Rutgers faculty ever since, and I've been studying volatile compounds ever since.
Yeah. You talked about, I know when you were sampling, at first I love that you are traveling with your petri dishes and everything else, always having that scientist hat on. That, you would even have to like come out and take breaks, right? Because it was so overpowering and so nauseating.
Yeah, I know I did. And I have a picture of my husband and a friend sitting in our front yard looking horrible. I took the picture. No one took a picture of me, but I sometimes show that picture of how unhappy they looked and how debilitating it was. And there was no electric power, so we had no fans. We obviously had no air conditioning, and it was hot. And remember, it's not just the contents of my house, it's the entire city.
Mm-hmm.
So if you got outside, it wasn't as enclosed, but it wasn't necessarily a mold-free environment because the plant life in New Orleans had been saturated. Much of it died. The grass died, a lot of shrubbery died, and so it was bleak looking, but it was better than being inside the house where the odors were enclosed. I'm very disappointed that the environmental experts who were looking for health risks after Hurricane Katrina, they tended to focus on things like heavy metals. And there was a lot of work on cholera, which they knew is a water spread bacterial disease. And almost nobody was looking at the mold. And I feel like it was a missed opportunity. I feel like there should be future opportunities because with global warming, we have more floods. And unfortunately, a combination of forces, insurance companies, a previous emphasis on black mold and a group of toxins called trichothecenes, and perhaps the fact that in general, the public health and medical community pays more attention to viruses and bacteria and fungi. There just hasn't been the appropriate scientific focus on the molds that follow climate disasters. Or find molds also can, follow some minor household disasters, like when your when your washing machine hose springs off from the wall, or an ice automatic ice maker. That's another villain where the water line will somehow break and it's behind the refrigerator and you don't see it. And so those cause small individual mold problems. When there's a climate disaster, though, everybody will share and have a mold problem. And the latter are where I hope there's going to be a wake up call from Environmental Protection Agency and places. We really need more research.
We totally agree with you there. And I know, even just Hurricane Sandy a few years later, one of our co-founders, Michael Rubino, I think when it's a wide scale flooding hurricane, it's in the news, it's on the radar, but the effects of that are felt for years after. And I know part of what he did, with his company is a lot of the time, because he was based out of New Jersey area, they were having to go back and re-remediate areas from Sandy from years before that weren't properly addressed. And to your phrase, which I think I'm going to steal, just add water, became these issues were continuing to impact homeowners and renters down the road. So this is something that I agree, we definitely need more research. We need to wake up, and increase our level of awareness because, there were floods in Kentucky, was it last
Mm-hmm.
summer, and things like that. So this is something even an individual or wide scale, I think is an important
Yeah,
topic.
and even dry California,
Yes.
these areas of California that have been drought stricken for years suddenly have the opposite problem. And I think there are going to be mold problems in California that we haven't seen in decades.
Yeah, like LA, I know. I mean, how many times I get flood alerts from there because I have some family out there and yeah, that's a perfect example too. Not one that's always on your radar. You think, oh, we're not impacted, as much by hurricanes. It's not really an issue, but there are other factors there certainly at play. So I'm going to ask you a loaded question then. So your curiosity was shifted a little bit after Katrina. You're like, oh, these mVOCs, they're making me not feel good. So, and I know this is not a black and white answer, but are mVOCs a health threat?
Well, certainly government agencies like the Environmental Protection Agency think that certain chemical mVOCs are health threats. And there are standards that have been issued for substances like toluene and many of the chemical solvents because it's been seen in industrial hygiene circles that people who worked in factories or whatever and were exposed to these levels were getting sick. The question is, are natural VOCs health threats? And that's where we get on tricky ground because we don't know. Uh, I'm trained as a geneticist, a fungal geneticist, and so when I got to Rutgers and was able to start a lab, I really started building my lab in 2007, 2008. So I've been at it for good 15 years now. What I decided to do is use my genetics training and study the fungal volatiles in what geneticists call model systems, of which perhaps the most famous, and most people have even heard of it, Drosophila fly, the fruit fly, has been studied for over 100 years, and it's little, it's inexpensive to raise. There's a lot of research on it, and you can do a lot of research in a small space on a relatively small budget. And so we started studying Drosophila flies, and our whole intent was to see if we could make the Drosophila flies sick. You know, could we kill them? Could we change their behavior? Uh, when you expose them in the larval stage, you can make them look kind of weird as they go through their development, and their wings might be bent or whatever. And it's a really wonderful model. And we soon discovered that just growing a mold over here and flies here and having a filter between so there was no direct contact. So they're sharing an atmosphere, but not sharing food or any physical touching to one another, that we could kill Drosophila flies by exposing them to growing mold. And we've published some things like that. Science tends to be reductionist. And because the kinds of compounds mold make change a lot while they're growing, what we decided to do was analyze a profile of what the molds were making after, say, 3 days growth or 5 days growth. And then after we'd identified the compounds, test them one by one. And so we did a lot of that. And to double on back, we rather rapidly learned that one of the best compounds for killing the flies was this 1-octantriol or mushroom alcohol, the 8-carbon alcohol. And that finding allowed us to start paying more attention to one compound. I still remember the day, and it's probably 11 years ago or so, when I was using Google Scholar, and I had done a lot of things about mushroom alcohol and fungi, and there was research on it in the mushroom growing trade, and there was research on it as a spore inhibitor. And somehow somebody had, from the entomology department, had used a word I'd never heard before called semiochemical. So I typed in 1-octantriol insect, and down came like 1,000 papers. It just blew my mind. This enormous literature in entomology on this compound that I thought was a fungal metabolite, and that the literature on fungi was very small, and the literature in entomology was enormous. And that gave me a lot of confidence that we were onto something big. That, hey, insects are sensing this compound and using this compound as a way to find fungi and perhaps avoid fungi, and that no wonder Drosophila is responding to it. It's one of the ones that's using it as an aversion compound. So that was good, and we've continued our work on Drosophila. I have struggled to get appropriate funding. I'm pleased with what we have found. I can tell you we can give Drosophila flies Parkinson's disease with 1-octantriol. I've written several grant proposals to try to move it into mammals, and I haven't been successful. So somebody else is going to have to pick that up. But I'm convinced that 1-octantriol and other volatile compounds do affect human beings and other vertebrates. I don't have the evidence to show it, but I believe when scientists study it, they're going to find a lot of effects.
Yeah, I mean, I think one of the things we hope at the foundation, or vision, if you will, is that people are going to live longer and healthier lives by breathing safer indoor air. And
Yes.
there can be multiple factors in your indoor air. So there's a paper you have, and I can even link to it in the show notes, and you talk a little bit about are some fungal volatile organic compounds mycotoxins. So some of the people listening today have heard about mycotoxins, and especially if they're being treated for SIRS or any mold-related illness, right? They're the secondary metabolites produced by certain kinds of mold under certain conditions, and informally, they're essentially a poison. But what's the difference between VOCs and mycotoxins for our listeners, and tell us about your thinking there, and where we may need to go in terms of our understanding.
Be a stickler for vocabulary. When you look up toxin in dictionaries, you discover that some people use it just synonymously with the word poison, and other people get more particular and say, oh, a toxin is a poison made of a protein. Mycotoxins are basically not, with a few exceptions, made of proteins. And so it's the broader definition. So these are low molecular weight poisons. And people have heard of arsenic compounds. Well, these are biological poisons. Most of them are not proteins, but they are made by living things. And in my research at my previous university, I was involved in showing how one of the worst of these fungal toxins, called aflatoxin, is made by a long series of biosynthetic reactions, and the genes form a cluster, and you can now find evidence of these genes in genomes. And there's a lot of research on mycotoxins. They contaminate our foods. The molds that make them are often weeds of vegetables, weeds of stored grains. And when foodstuffs are stored inappropriately or grown inappropriately or cooked and then not refrigerated appropriately, these fungi can grow very rapidly and within 48 hours produce levels of toxin that if you eat it, make you sick. Some of the toxins have bad flavors and bad odors. So, I mean, sometimes when the mold does that, you notice it. There are a couple, though, that don't leave much evidence, and that's problematic. The World Health Organization and the Food and Drug Administration and many other organizations have to, made guidelines. So basically, most of the time when people are made sick by mycotoxins, it's because they've eaten them. We don't necessarily eat volatiles, and they're a different kind of chemical thing. They're also small. I've read a lot of people say, oh, they're secondary metabolites. I don't think most of them are because of they're these small biodegradation products, but that's definitionally picky. I wrote a paper in which I was just trying to be provocative to point out that I think some volatiles can be poisonous, and you can say the word that therefore that they're toxins. I know that they're poisonous to Drosophila flies. I know that they're poisonous to other things when I expose them, like we've tried doing little worm called the Ceneropsis elegans, and you can kill those worms, and you can kill plants, and there are a number of things you can kill with volatiles. So I believe that some volatiles are toxic. Whether there's the same as substances called mycotoxins is definitely a linguistic quibble. It depends on how you're using the language, but I think we can agree on the word poison, toxin, something that can kill things. Mm-hmm. And I do believe high concentrations of some volatiles can kill things.
Yeah. So I hope we continue to look into this as a society and research it more. So there is an interesting research study, and I hope you can elaborate on it. You talk about I told you I had heard a talk you gave at Cornell. We inhale VOCs, but they can also be absorbed through our skin. And you had a colleague, I believe, from Denmark who's done some dermal absorption studies on VOCs. Can you tell us about that? Because I think it's super fascinating.
Yeah, it is. My colleague had this interest in volatiles, mostly industrial chemicals, and with scientists in Denmark, they organized themselves and created a clean room, and they had an oxygen mask system so that they could go into a room and wear little shorts and have a certain amount of a volatile introduced into the room, and while they were breathing other air. And they stayed in there for, I don't know, 4 hours or 6 hours, and then spent the next week collecting all their pee and poop to see how much of this chemical they'd absorbed through their skin. And remember, they're breathing clean air, so they weren't inhaling it. And they found out that it was about the same amount they would, about 50% of the level they would have if they'd been breathing it in. So we can get exposed to a lot of volatiles through our body, that we can absorb them. And we don't necessarily think of that as how we get exposed to chemicals. We think of inhalation, we think of swallowing. We don't necessarily think of ourselves as absorbing them through other body parts. And that too has been under-researched, but it's of interest. And, we know that certain like topical ointments and everything will get in. And it's interesting, there are also elements in both traditional Chinese medicine and the Indian medical traditions of using incense type compounds and steam rooms and stuff with herbs for certain medicinal treatments. And I wish we had more study on that, because it shows that human beings have figured out that, hey, sometimes being exposed in steam in an enclosed space to the extracts of certain plants may actually be doing good for you. May actually sometimes be doing bad for you, but I wish there were more research. It's all a little too iffy for my scientific taste, but I think there's something there,
Yeah.
and it falls into this category of we need more research. There's so many interesting things about human and other animal physiology we don't understand, and I think one of those mysteries is how much of our biology is being done in the gas phase,
Yeah.
that not just in water, but things that we inhale or things we're exposed to on our skin.
Well, if you're from a large foundation and you're looking to fund some research, we do some small scale funding. Please give Dr. Bennett a call. I know she has lots of research ideas she would love to see come to fruition. But to kind of wrap it up, and I know I've heard you say before that you don't own a TV, but there is a show called it's like The Last Among Us, and it's about this fungus. I believe it's even based off a
The
comic book.
Last of Us, yeah.
The Last of Us, thank you. And, it spreads throughout the world and it shows that this like fungus is communicating. And I've heard you say before that fungi and other organisms use VOCs to talk to each other. And you kind of alluded to this before. What do you mean by that? Because it sounds like
Well,
something
let me
more.
step back. I may not have a TV, but I have a son who does, and I binge watched the entire series over a 2-day period, and it's a fun, kind of horror story about fungi that turn people into zombies. And there, I think you need physical contact. When I talk about using volatiles to talk to one another, though, it's like we can talk without physical contact. We just do it through our ears, and it's a way of communication. And biologists who study cell development and cell signaling have often adopted the language of semiotics and talking about how we communicate with one another through language. Have adopted that language to talk about organisms communicating one another through chemicals. And that's what I mean about talking to one another. And it's a way they can do it at a distance. And in our research with, say, the Drosophila fly, the difference in our research with the volatile work and most of what has happened with looking for toxins in Drosophila, it's usually you're feeding the flies the toxin, or you're somehow physically exposing them to the toxin. What we have is a distance. And so there is a communication element. And we know that the toxic elements can pass through the air. And that's a model that's showing that it can have a negative consequence. I haven't told you about the fact that some of the students who were studying the flies got interested in plants and discovered that some of our same volatiles were doing good things to plants. And that's when I broadened my view and I said, hey, these volatiles are not just necessarily toxins, but some of them in biology are actually useful for a fungal species to send a signal to a plant species to tell the plant to grow faster and flower faster and make more chlorophyll. And we have a good bit of evidence that some of the same fungi that kill the Drosophila flies can make plants grow better. And again, no physical contact. And that's what I mean about the signaling and talking to one another. Organisms have evolved the use of volatile compounds for long distance signaling. They don't have telephones, they don't have language the way humans do, but they have chemical language, and they use that chemical language to talk to one another.
Yeah, that's fascinating. I appreciate the more I learn about the complex ecosystem that's fungi and everything that's created, like how intelligent it is and fascinating. So even though
And how complicated, how
it's
many
complicated,
organisms are part of it.
yeah.
It's like we think of sociologists studying cities and how complicated cities are. Well, just a square foot of garden soil is probably as complicated as Manhattan.
Yeah, yeah, it's super interesting, and I appreciate you being, your career and your focus and everything that you've done to open doors and ask questions, because it really, sets the stage for important work and overall, improving our health. And so, thank you so much for being here. And
Sure.
I appreciate your time. We'll link to a couple of the research papers in the show notes that you
Well,
mentioned.
thank you, Ms. Seymour. You are a very sensitive interviewer, and you've obviously learned a lot about mold, and I hope that you can help other people learn more about how fungi grow inside our houses and may sometimes not be good for our health.
Yeah. Well, thank you. Thank you so much. And for everyone listening, if you found this helpful, do me a favor and head on over to changetheairfoundation.org and sign up for our newsletter because it really is the best way to get great interviews like this directly to your inbox. We'll see you next time. Thank you so much.